Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about UFOs from a black hole, and I don't even know what that means. And of course, taking listener questions about all things in this beautiful universe, because that's exactly what this show is about. We record every Thursday at 4 p.m. Eastern, and you can follow along online or leave a voicemail. Go to spaceradioshow.com for the links. And in today's Blue Shift, I'll be talking about sailing away with me. But first, the news. Yes, it's happening. It's happening. Did anyone else hear those weird little beeps while I was talking? I think it's the questions. Okay. There we go. Sorry about that, folks, if you heard that. If you didn't hear it, then I just look crazy. But what else is new? Hello, Space Cadets. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State and the Flatiron Institute. And for the next half hour, your Agents of the Stars. We got an exciting show for today on Space Radio where we talk about all the beautiful things in this very large universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here at Spaceman Studios in New York City. So leave a voicemail at spaceradioshow.com to get yourself on the air. You can also follow along with our Space Cadets tuning in live from around the world, including but not limited to Virginia Beach, Virginia, Reno, Nevada, Pell City, Alabama, Halifax, England, London, UK, Barkhamsted, Connecticut, DC, just DC, Sterling, Virginia, Ashburton, New Zealand, Lancaster, California, and Vipava, Slovenia. You know, Reno, Nevada is where I've had the best tortilla chips I've ever had in my entire life. There you go. Good job, Reno, Nevada. We'll take questions from the Space Cadets following along on the live streams too. Seriously, folks, I've only prepped 3.5 minutes of material, so get those questions in. Yeah, okay, so you guys did hear the noise. Yep, it was exactly Discord notifications. I think I muted it. Sorry, I got my laptop repaired, and so I had to rebuild everything, and so all of my little favorite settings were gone. Yeah, Larry, it's good to be back. It's good to be back. All right. Oh yeah, this news story. Have you guys seen this news story about the UFOs coming from black holes? It's pretty juicy. It's pretty juicy. Hot off the presses. Before I start taking calls, I want to share some interesting bits of news I caught recently. And man, it's hard to ignore a headline like UFOs are coming out of black holes and altering galaxies forever. Wow, what a fun headline. I mean, you see a headline like this, you just have to click on this is pure clickbait, right? Like you just have to see it, like black holes, UFOs, altering galaxies forever. Like there's a lot of fun words in this sentence. And then you actually click on the news article and actually bother to read it. I know, which is a very strange thing to do, but I was just too curious. It turns out that UFOs in this context doesn't stand for unidentified flying object. It stands for ultra fast outflow. Now, I know probably like 10, 20 years ago, there was a few astronomers sitting around and they were looking at outflows near black holes. And they're like, man, this thing is very fast outflow. I know. What if we call it an ultra fast outflows? Then we can type UFOs into our papers and we can have lots of fun. And everyone's like, brilliant idea. We're all going to do that. Fine. And then they go to communicate the results to the public or publishers or editors, and journalists are like, are you serious? UFOs coming out of black holes? And they're like, yeah, ultra fast outflows. But you said UFOs, right? And they're like, yeah, it was just a joke. Never mind, it's already printed. Well, the actual science is pretty interesting. Black holes are black. Once you fall into a black hole, nothing escapes, but you can escape the vicinity of a black hole. all those powerful energies, all that going on can drive outflows. Sometimes they're fast, sometimes they're ultra fast outflows. And this hot gas escaping from the galactic core can blow away material. It can prevent star formation, can shut things down in the galactic core. So we see this relationship between black hole mass and properties of the galaxy, its host galaxy itself. And I'm not talking little black holes, by the way. I'm talking about the supermassive black holes in the centers of galaxies. So we see this interaction, we see this correlation. We know that there's some sort of what we call feedback mechanism at play, where the amount of material falling into a black hole, some of it escapes, prevents further material from falling into the black hole, regulates the growth of black holes over the course of billions of years. Sometimes the outflows from the vicinity of the black hole are fast, sometimes they are ultra fast, and hence they become UFO. I can't decide if I'm mad or not. On one hand, it's just fine. The paper's interesting. It's kind of boring. I mean, it's a science paper. It's very dry. It's measuring velocities and all that. It's fine. UFOs, okay, cute. I get it. I get the joke. Ha ha. We all had a good laugh. If it weren't for UFOs, if these things were seriously called like very fast outflows, would it get this amount of press coverage? Probably not. So yeah, it's getting more people interested in the science. 98% ballpark in here are just going to read the headlines and think that scientists found UFOs coming out of black holes. I don't know. You decide. You tell me if you're mad or not. Go to spaceradioshow.com and let me know. What do you think, Space Cadets? What do you think of these headlines? I'm literally staring at the headline right now. UFOs are coming out of black holes and altering galaxies forever. Quote, it's all very new science. I don't know how to feel. I don't know how to feel. Tell me how to feel, Internet. I can't make decisions on my own, so could you please inform my feelings? That would really help. All right. Lots of Space Cadet questions. We do have a bunch of voicemails, so I think I'm going to do the usual thing, do a voicemail or two for the first segment, and then go over to the Space Cadet questions for the second, longer segment. Kevlar, yes, that is correct. Nothing can escape a black hole, but you can escape the vicinity of a black hole. But once you cross that horizon, you're done, but you can get close to the event horizon and then still escape. Ooh. The chat is, the Space Cadets are divided, reflecting my divided consciousness. So we'll do some questions, and then we'll see how we feel after we do a couple questions. Sound like a plan? Sure. We've got a voicemail ready to go. Greg, play the tape.
I have a very simple question. How does gravity work? ? And when will I get my anti-gravity belt? ? I have been asking this question from all you physicists for years and years, and all I get is like blank stares. I want my anti-gravity belt. When will I have it? I'll accept that. Just tell me when I'm going to get my anti-gravity belt.
Okay. Thank you for the question, Richard, period. Happy to talk about gravity and anti-gravity belts, period. The answer might surprise you, ! And you're very serious about this, so I want to address it with utmost certainty. How does gravity work? Well, we have a very good picture of gravity. Our picture of gravity, of how it works, is general relativity, Einstein's theory of general relativity, where gravity, as we call this force of gravity, is really bends and warps in space-time itself. So if you have a thing that has mass or energy, that thing distorts space-time around it in a certain way, and then that distortion of space-time informs other objects how to move in the vicinity of that thing with mass or energy. That is what we call the force of gravity. That is how we explain it today. That is our best explanation so far. We know that general relativity is incomplete. There are places in the universe where general relativity breaks down, like in the centers of black holes and in the earliest moments of the Big Bang. We do not have a theory of gravity for those scenarios, but everything else seems pretty kosher. Now, when it comes to anti-gravity, you may have noticed that gravity is almost always an attractive force. Like two things always want to be pulled together and they don't want to be repelled apart. There is one very important exception to this. We do see right now in the present day universe anti-gravity. So you heard it here first, folks, or maybe not. Anti-gravity exists. Anti-gravity is real. The thing we have a special name for this one particular instance of anti-gravity. We call it dark energy. Dark energy is the accelerated expansion of our universe. Not only is our universe getting bigger and bigger, it's getting bigger and bigger, faster and faster every day. Accelerated expansion. The universe, it's ripping itself apart at the seams. This is anti-gravity. You can set up. General relativity does allow you to have anti-gravity. It's kind of tricky, but you can do it. You're never going to see it. I shouldn't say never. You're highly unlikely to ever see it in normal everyday scenarios, because in order to set up the right conditions for anti-gravity, you need not a lot of stuff and you need a lot of vacuum, and that vacuum has to have certain properties, et cetera, et cetera. This is how we get dark energy. This is how we get anti-gravity. So, Richard, period, you will, I'm going to go ahead and say it, likely never get your anti-gravity belt, period. We've got time for another question. So, Greg, are you ready? Of course you're ready. Play the tape.
Hi, my name is Scott, and here's my question, to be very brief. Is it possible for a planet to have a moon that is composed of only gas? So we have gas planets. Is it possible for there to be a gas moon? And if so, how much mass would that planet have to be? That's it. Thanks.
That's it. That's a cool question, Scott. I really appreciate it. I'm going to start answering it and then I'll go to the break, but I'll finish answering it after the break. Scott's asking about moons, and we have gas giants in the solar system. Those gas giants have moons, but the moons themselves aren't very gassy. So Scott's just wondering, is it possible for a gas planet to have a gas moon? Great question. And I'm just going to tease you, and you're going to have to wait till after the break. I'm Paul Sutter, and this is Space Radio. This show is brought to you by you. Go to patreon.com/PM Sutter. That's P as in Paul, M as in Matthew, Sutter as in Sutter. Patreon.com/PM Sutter to learn how you can support the show. It can be just $1 a month. It could be $100 a month. I'm not going to complain if it's either of those or both of those. Just please go to patreon.com/PM Sutter. It's how you keep Space Radio going, and it's how you keep all my education and outreach activities alive. And I will see you after the break. Yeah, gassy moon. Yeah, too many jokes here. Too many jokes. So I'll finish answering Scott's question, and then we got lots of Space Cadet questions as usual. George Lancaster wants to live forever by orbiting a black hole. Other than Hubble, what other deep space probes do we have? What's going on at the center of a black hole? Love all these. I'll just go right down the line. Matthew DeFleury, I'm the wrong person to ask on that for that. Sorry. You're going to have to ask a nerd. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got tons of questions ready to go, but remember, you can join the conversation by leaving an online voicemail or by following the live streams. Check out spaceradioshow.com for all the links. Now, getting back to Scott's question is, can a gassy planet have a gassy moon? My first instinct is to say no. Then my second instinct is nature is really good at surprising us, especially when it comes to exoplanet systems. Like, you can pretty much imagine any scenario, and we've already spotted an exoplanet system outside the solar system doing that thing as crazy and wild as you can imagine. So I'm not going to rule it out, but it is going to be very, very difficult because all the gas that is forming in the vicinity nearby a newborn gas giant planet is just going to get sucked up by that planet from all its massive gravity. All the gas is just, because gas is so light, it's just going to go, you're going to get a gas giant and there's going to be no more gas. It's going to be very, very hard to form a moon large enough that's capable of hosting a thick gaseous atmosphere. Now, we do have moons in the solar system with thick atmospheres like Titan, but I'm talking about like a gas giant thick atmosphere. It's just going to be very, very difficult to get enough material together in orbit around something that's destined to become a gas giant, because that thing's already massive. That thing's already eating up all the stuff, all the rocks and ices, and especially gas. And just getting enough stuff to make a moon around that is going to be challenging. You're just going to be left over with some stray bits of rocks, some stray bits of ices, maybe a little bit of gas that you might steal here and there. Other than that, it's just going to be tough. But I'm not going to rule it out, because it's not like I've done like the complicated simulations and 100% ruled it out. I'm just going to say it's extremely unlikely. But great question, Scott. Speaking of slightly science fiction scenarios, over on the chat, the Space Cadets George Lancaster is asking, can a biological entity orbit a black hole and achieve relativistic slowdown without being ripped apart? Very, very fun question. This depends on a lot of things. So what George is asking about is, when you get close to a strongly gravitating object like a black hole, time slows down for you. You feel normal, but relative to the rest of the universe, you're super slow-mo. This happens everywhere, it even happens on the Earth. We can measure this, no big deal. Around a black hole, big deal. The challenge, one of the challenges with getting close to black holes is their extreme gravity, and extreme differences in gravity can literally rip you apart head to toe and twist you up. It's just nasty. They can just shred you before you even reach the event horizon. For small black holes, the black holes that are a few times the mass of the sun, you're just done. You're just cooked. You're not getting anywhere close enough for this gravitational time dilation to really be serious. With a supermassive black hole, however, you could potentially do this. With one of these giant black holes, the ones that are surrounded by UFOs, still haven't decided how I feel about that. You can approach the event horizon, experience this gravitational time dilation effect without being ripped apart. And that's because the event horizon, the size of the black hole is so big, the event horizon, this boundary, is so far away from the central singularity. The central singularity is where all this stuff is that fell into a black hole, and you're way far away from it. That boundary, the event horizon, is way far away from the singularity. So you can survive nearby the event horizon. You can get closer and closer to it. The closer you get to it, the harder it's going to be, because, man, it really wants to pull you in, so you have to fight all that gravity. is you're going to have to blast your rockets really hard, but you can hover above the event horizon, you can live, and you can experience this gravitational time dilation, and you can escape, and you can skip forward into the future. I'm going to recommend a more fun thing to do instead of just hanging around the event horizon of a black hole, blasting your engines, trying to get close to the speed of light so you're prevented from falling in. Why don't you just skip the black hole thing and just go really fast around the universe? Because you also get a time dilation thing just by going fast. So if you've got all that rocket power, if you're able to withstand the pull of gravity near a black hole, you've got some serious horsepower under the hood. So why use it to go somewhere interesting? Like, I don't know, a nebula, or go check out a supernova. Don't get too close. But you might as well go to Andromeda if you've got that much rocket power. Man, have some fun. Black holes, man, black holes are boring. I mean, yeah, they're the boundaries of known physics, but like astrophysically, there's so much cooler stuff going on in the universe. Speaking of black holes, Bob over on YouTube is asking, is the black hole singularity or does it have some size? So, speaking about a singularity, all the stuff that fell into a black hole is in the singularity. So how big is it? We don't know. We don't know. Like I said, it's beyond known physics inside of a black hole. According to general relativity, it's infinitely small, but we know that's not true. We know that's not correct. Can't be infinitely small. That's not really a thing allowed by our universe. So it has to be something, but we don't know what that something is because we don't have the proper tools or language to describe it. Also from Bob, other than the Hubble, what deep space probes have given the most to science and astronomy? Oh, man. So Hubble gets all the glory, and trust me, Hubble is a fantastic instrument. I love the Hubble. Big fan of the Hubble. Hubble fan. It's not the only space telescope up there. We've got lots of space telescopes. We have a space telescope for almost every wavelength. Like we have the Spitzer infrared. We have the Chandra X-ray. We have the Fermi gamma ray. We have the Planck cosmic microwave background. That one's not running anymore because its mission is finished. We've got Kepler, formerly Kepler, looking for exoplanets. Now we have TESS looking for exoplanets. When you do the investment to put a telescope up in space, you want to make sure you get your money's worth. So there's going to be a lot of data pouring in. It's not just going to be a quick little, okay, well, we'll do a few hours of observing and then we're kind of over it. No. These are multi or sometimes multi-decade missions probing everything from the formation of stars to finding exoplanets to cataloging galaxies. It's just on and on and on. Like almost every astrophysical question or astronomical question that we have is in part answered by a space telescope. Of course, with a network of ground-based observatories and telescopes down here, don't worry, don't discount good old Earth. But I guarantee if you're interested in something astronomical or astrophysical, part of our understanding of it comes from some space telescope. What will the future be with the grounding of the Hubble and eventual decommissioning of the Hubble and the fact that the James Webb Space Telescope is kind of delayed? That's got to be another show. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. I know. I get sad thinking about the future of space telescopes because there just isn't a lot going on. Because we're all just kind of waiting for the James Webb. And then if it's delayed by like another 5-10 years, no other major telescope will go up. Because we're all waiting on the Webb. I need a nap. Just too much. You guys ready for the Blue Shift? I think I am. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And you know this whole Astro Tours thing, which I've been doing it for a few years now. I absolutely love this idea. It's go somewhere beautiful, take a bunch of other nerds, nerd out for like a week, experiencing science. So not just talking about science, not just learning about science, but being immersed in science, being embedded in a place where nature is on full display. And we can just sit there and enjoy it and be a part of it. I've done trips all around the world through Astro Tours. It's such a blast. Happy to announce our next one. It's a cruise. We've done a cruise before, and I was feeling itchy. It's time for another cruise. We're going to do a cruise of the Caribbean in August of 2020. It's going to be so much fun. We're leaving from Galveston, Texas, which means we're going to do a tour of the Johnson Space Center because, of course, how could we not look at some giant rockets and look at like the heart of NASA operations? We're going to leave from Galveston, Texas, 7-night cruise. We're going to have a bunch of at-sea days. So I'm going to do recordings of this very show, Space Radio. We're going to do some other special talks and other presentations. We are going to go explore Mayan ruins in Cozumel and Belize. And let me tell you, the Mayans were huge astronomy nerds. They loved Venus. They loved the moon. They were tracking it. They had the most accurate calendar up until like the medieval Renaissance period. Like they were beating everybody in terms of calendar accuracy. They were stupid good at it, which means they were smart good at it. They had temples aligned with key celestial events like solstices and the rising of Mercury at certain times of the year. Like it was just like they knew what to do. And these temple complexes are all about astronomy and their mythology. And then, if that's not enough, we're going to do stargazing every single night off the deck of the ship. I'm going to bring some big bad binoculars. Telescopes aren't the best on a cruise ship. Binoculars are really awesome. And every single night, stargazing. Me with you. Star party. In the middle of the Caribbean. Like, how awesome is that? Exceedingly awesome. Go to astro.tours. That's astro.tours. That's a link to the website. And check out the Sea in the Stars, August 2020. And there's a registration form to get you started. Just a small deposit, get your name on the list, and then we'll make this trip happen. I can't wait. August of 2020. Announced here for the first time on Space Radio. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of Space Radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Go to patreon.com/PMSutter to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio for making this show possible. Catch the live stream every Thursday at 4 p.m. Eastern. Visit spaceradioshow.com for more info and links to the live stream locations and the episode archive. You can also follow me on all social at Paul Matt Sutter. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. We did it. We did it. We made an episode of Space Radio. How do we feel? Are we feeling good? These are my show notes, by the way. Have you guys noticed? Have I shown you these? My script. My little scripty bits. Yeah, yes, like 5% of the show is actually scripted. The rest I have absolutely no idea what I'm going to talk about week to week. Thank you, everyone. But I need a title. Any title suggestions for today? Let's not be crass, folks. No crassness, all right? Let's maybe something uplifting, something hopeful, something cheerful, something that speaks to the better part of ourselves. Gas moons. Gas moons. All right, the name of the episode might be Gas Moons. Hate it when I get a bad case of gas moons. Gas moons and the betterment of humanity. I actually like that. Gas moons and the betterment of humanity. Wow. It just might be dissolution. Paul does science again. Cheerful Larry. Larry Beckham cannot do cheerful. Scott Bragdon never heard of gas moons, so okay. Gas moons and the betterment of humanity. That I like how that rolls off the tongue. And it's not